So much. Good to see y'all. Hope you're doing okay. I had an all right weekend. It was my birthday, which was nice, and I promptly got food poisoning, so that was less nice. I share that to say we might take a couple breaks today, so I can just go walk around, and I'm very slowly starting to eat food again. Uh, so I apologize. We have to take a few breaks. Excellent. I'm excited to talk about binary search with you all. I think our previous lesson on linear search hopefully felt pretty approachable. It's more just a reminder of how basic JavaScript works without uh, getting into React land and all of that. Today we're going to talk about binary search, and as you'll see, there's some interesting decision points that we can make in our algorithms to improve their efficiency. That's the plan for today. The other plan is if we have some time left, I'll be happy to go over some of the content from Project 9. Uh, I'll say it doesn't feel like it makes a ton of sense for me just to redo the entire project. I think you all went through that with David. So if there are particular questions you all have about Project 9, please do start to percolate them, maybe write them down so as we get to that, we can try and uh, address any specific questions you all have about React or APIs or anything like that, as opposed to just meandering around, which is fun, but it'd be better to address the different issues that you all have. All right, excellent. Go ahead and share my screen. Thank you for all the happy birthday wishes. Yes, I am old. It comes for us all, for better or worse, but nice nonetheless. All right. Okay, we're good to go. So plan again today, binary search. You can see over here, it's actually not too much to go through. It has all these different little slides that just say binary search. This is going to be us just walking through. Ivan, bless you for that comment. Much appreciated. So we're going to go through this. There's a couple options or opportunities for us to practice pseudocoding out as well as implementing binary search. And then our final activity is actually about us implementing binary search in a more realistic scenario. So that is definitely a good opportunity for us to practice. So our goal for today, as I've been talking about multiple times, we're going to explore binary search, a more efficient way to search in sorted data sets. We'll talk about that in just one moment. We're going to understand how it compares to linear search in terms of performance and be able to compare and contrast the two. So our goals, hopefully we're able to understand the concept of binary search, implement a binary search algorithm in JavaScript, and compare the performance of binary search with linear search. We're going to do some initial investigations on that. All right, I'm actually just going to give you all a minute or so to take a look at this GIF. So these two little lines right here are showing two different types of search algorithms. One on the top is binary search. One on the bottom is sequential search or linear search overall. So take a moment to look through here and just try and get a sense of what this image is trying to demonstrate. All right, so hopefully y'all have had a few seconds to take a look through this. Oh man, y'all gas me up in chat. I appreciate it. So the goal of this, right, of this search algorithm, if we're taking a look at this, it looks like we're looking for the number 37, and we have two different search processes happening at the top and the bottom here. What are some of the differences you notice between these two things? What are some of the differences you notice, for example, with binary search? What are some of the differences you notice with the sequential search? Yeah, driver sharing binary search seems like it's the better choice as it's estimating based on the value it picks, while sequential goes through each one to get the value wanted. So I think what I'm hearing there is that binary search looks like it's making decision points, whereas linear search is just like, let me take a look at the next one. Let me take a look at the next one. Excellent. Yeah, thanks for that. Other thoughts, just things you notice between these two, other things you're noticing about this situation. I see a few folks typing. Much appreciated. Give you all a moment or two. Ooh, Joseph is pulling out some fancy terms here. So he says binary search is using divide and conquer, while sequential search is conquering one after another. Sure, divide and conquer is definitely one of those terms that can be really helpful in thinking through and understanding, communicating about this algorithm. Yeah, appreciate that, Joseph. These are all good things to call out. Sorry, please finish your thought. I'm going to continue, but please share it out so we can make sure not to miss anything. I'll just identify some of the other differences that are in here. First of all, you might have noticed there's a different number of steps it takes to find this number, right? So with sequential or linear search, we're having to go one by one, versus up here, we're actually only really taking 3 steps to find that number. The thing you might notice about this, remember with linear search, we did not have to have the numbers ordered in any particular format, right? Because it doesn't really matter. We're just going one after the other. Here, notice these numbers are in a sequential order, right? They are each number following in the index is bigger. This is important for binary search. So we can notice a few differences here. We're going to talk more about efficiency in our next lesson and what efficiency actually means when we're talking about algorithms. Hopefully just here though, even without us really diving deeper into it, you can just get a sense of like, oh yeah, we're doing less stuff up here with binary search, right? So let's talk about this algorithm and how it's going to end up getting implemented. So binary search is a searching algorithm used to find the position of a target value within a sorted array. So that is the really key part here. The algorithm compares the target value to the middle element of the array. If they are not equal, it eliminates the half in which the target cannot lie and continues the search on the remaining half. This process of having the search interval repeats until the target value is found or no elements remain. So we can see that again up here. What's happening when this first gets searched, we'll give this a second to restart here, is we're going to find the middle point within this array. So we first check the number 23. Because 37 is greater than 23, we don't have to look at anything below that, right? We can just completely ignore it because this array is sorted. If the array was not sorted, we could not make that assumption, right? But because it's sorted, we can now determine, oh, great, if I found 23 here, I know I can just look ahead, right? We keep performing that process multiple times, almost as if we're repeating the process, we're looping the process, right? Until we find that number, or as we'll see, until the number is not found. So that's the idea behind binary search. And a couple other examples of what this might, what this is like. If I guess now I'm again showing my age here. So if you all have a phone book or have used dictionary, an actual physical dictionary at some point in your life, right? When you're trying to find a particular word, you don't just go from the first letter and start going, okay, well, let me look at page 1. Maybe I don't know, the word I'm looking for that starts with an N is at the first page. Nope. All right, let me go to the second page, right? You're going to start somewhere in the middle and maybe start to flip around until you find the thing you're looking for. That's the same idea here, is we're just slowly cutting down different segments of this array because the content is sorted so we can find a specific thing we're looking for. All right, as it says here, the primary requirement is that the array must be sorted in some way. So we're going to use numbers for the majority of our examples here today. But again, that could be alphabetical. It could be sorted by some other value that you're going to be searching through. It just has to be sorted in some way. All right, so why do one over the other? So binary search is often chosen over linear search for several compelling reasons, especially in situations involving large sorted data sets. So efficiency, binary search significantly reduces the search time by having the search interval at each step. This means that you can find what you're looking for much faster compared to linear search, which checks each item one by one. Speed for large data is kind of the same idea. So the bigger the data set, the more advantageous binary search becomes. For large arrays, the difference in search time between binary and linear search can be substantial, making binary search an excellent choice for quick data retrieval. Just a brief note on this. If you have a collection of 2 items, it doesn't really matter which one you're using, right? So if you have a really small collection of items, there's not much of a benefit between cutting out half of it, of one side of the collection, and then picking the other. But as it grows, the benefit of constantly slicing in half, the benefit of dividing and conquering, as Joseph pointed out, is going to become more and more apparent. Predictability with binary search, given a sorted array, it's easier to predict how many steps it will take to find an element or determine it's not present. This level of predictability is very helpful in planning and optimizing algorithms for performance. We got widespread applicability. The concept of binary search is not just limited to searching in arrays. It's also used in various other computer science problems and algorithms. Logic can be applied to efficiently solving tasks such as finding an item in a list, searching through ranges, and more, making it a versatile tool in your toolkit. What this one is trying to get across is that this process that we're going to go through of sort of, okay, based on the information I have, I'm going to be able to make my algorithm faster by cutting out an entire section of the data set. That's a common idea that will come up multiple times. And it says here simplicity and practicality. So despite its efficiency and the advantages it offers, binary search is straightforward to understand and implement. This simplicity combined with its powerful capabilities makes it an attractive choice for solving problems more quickly and easily when dealing with sorted data. It's pretty simple. As we'll see once we start writing the code, it can feel a little complex at a certain point. But hopefully by the end of this lesson, you all can understand the process we're trying to go through and feel confident in it. All right, blah, blah, blah. Let's take a look at another example here, right? It's a little bit slower. All right, so how this works, again, is that with binary search, the first place we're starting to look is going to be whatever is right in the middle of our sorted data set. That's different, remember, than linear search, where we're just going to start at one end and just start to walk our way through. The important thing about linear search was that every data point was connected somehow. There's some sequential order. In this case, we're going to start by looking at the middle item. So if we were looking for the number 5 and it just happened to be the middle item, fantastic, we got lucky, right? In that case, what we're going to do is return true. Depending on the algorithm, we might return the index, just like we did with linear search. Whatever the case may be, we're saying, great, we did indeed find it. However, if it doesn't match, we can discard half of the current array, including that value. So it says here, when we are searching, we are not eliminating the side of the array we aren't using, but ignoring that part of the array. So I think what this is trying to tell us is that we're not actually adjusting the array, right? We're just going to change where we're looking. So for example, if we were looking for the number 3, we would be able to take a look at that middle value and say, okay, well, 3 is less than 5. That means we don't need to check anything to the latter half of this array. And so we're just going to, our new subarray, our new section underneath this array is going to be just inclusive of everything from the beginning of the array up until the current index, the middle index, -1, right? Where we don't have to include that number anymore. Same thing here. If it's greater, we'll cut in the opposite direction. So if we were searching for 8 in this case, our first step is to check 5. 8 is indeed greater than 5. So we'd be able to ignore the number 5 and all the items less than 5. We then conduct another round of binary search on the remaining half of the array. So we can see we have this one step that's happened. We're saying check the middle. If it is what we're looking for, great. Otherwise, go ahead and cut half the array. We're going to do that same process on these 2 values of 7 and 8. So we start in the middle of the array. This subarray, right, actually has 2 items. There's not a perfect middle. If it's split evenly, I would say typically you find folks want to round down to find the index that's 1 down. It doesn't actually matter. You can pick either direction. You just have to pick a direction, right? So in this case, our middle value becomes the value 7. That is also the start value, right? But it's only a list of 2 items, so there's not much of a middle to be found. We then ask, okay, is this middle value, Is our value of 7 equal to value 8? No, it is not. In this case, we're going to check, is it greater than or less than that value? In this case, 8 is greater than 7. So then we do the same thing again. And now we have our another subarray that this time just has one item in it. So with this remaining item, we're going to check the middle of our single item array. And in this case, the middle is the start and the end, but this is indeed our target value. So we're cutting in half, finding the next half, cutting in half, finding the next half, so on and so forth. If for some reason we were not able to find that target item, we ended up where we had our subarray was basically nothing, right? Then we're going to return false or -1 like we do with linear search, right? We're going to say there's no index that matches this target value. That's it. Actually, before we do this, let me ask you all, any questions about this process? Any questions here? What's the feeling? Feeling like, yeah, or is it like a just tears in the face? No, nothing else other than React. Why are you talking to me about this? All right, Dragish says, feels good so far. Yeah, I think this feels pretty straightforward. And then we'll take a look at the actual code itself. It's not bad, but it can be a little tricky. All right, so again, we're just cutting in half, checking the middle, cutting in half, checking the middle. So suppose you have the following sorted array. Using binary search, write the steps you would take to find element 9. So here's what I want you all, so you can write this out, or you can type this in chat. Which numbers are we going to check on the way to getting number 9? So which values are we checking? Number 9 is in here. We can kind of just scan it quickly and take a look. So what numbers are we going to end up checking before we actually get to the value 9? All right, we got some folks typing. Oh, several people are typing. Just, I was feeling sick this weekend, but I'm already feeling better just seeing that. It's making me feel great. All right, that's a suggestion from Dragosh. Thank you, thank you. Other folks, what do y'all think? Hmm. Joseph was asking a question of when the array is even, it was a bit confusing as to whether to use the left value or right. What happens if I decide to use the right value instead of the left? Yeah, I can talk about that. It adds a tiny bit of complication versus them always being odd. All right, getting a few other suggestions here. Lots of question marks. I understand. No worries at all. All right, let's walk through this, y'all. Thank you all for sharing the chat. So first of all, let's take a look at how many elements are in this array. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means we have an even size array. So what we want to do is we want to find what the middle is for this, right? So the middle, the first step we're going to do is we're always going to find the middle of our array. The middle here is right here, right? It's actually just right in between 12 and 14. And so this gets to the question you were asking, Joseph, about like what happens if I decide to use the right side or the left side, or like what am I doing here? Right. if we were going to try and get the index of right here, this is like what, 0, 1, 2, 3, 4, 4.5. There's not an index 4.5, right? So we can't ask that. We have to pick 4 or 5. It does not matter if you round down or round up. We'll round down in our case. We'll take the lower value. But if you wanted to grab the upper value, that's fine. You just have to be consistent throughout. You can't swap between, right? So in this case, we're going to say, okay, well, I can't grab the exact middle. So I'm going to round down and grab this value right here. So the first middle value we're checking here would be 12. If you picked 14, that's okay. Doesn't really matter. You just got to pick a process here. So our first question then is 12 the value 9? What do y'all think? Seems like a no to me, right? Seems like we're not looking at the same values here. So in this case, if it's not the target value, then we want to compare our target value to our current middle value. So 9, is it less than or greater than 12? That's the question we're asking ourselves. In this case, 9 is less than. So it's hard to do, but imagine you don't know any of the numbers that are right here. You don't know any of the numbers that are up here, right? All we've done is say, I'm gonna take a look at the middle. All right, all I see right now, this is all the computer sees, is I'm just looking at 12. What I know is if we're looking for 9, everything above, everything with an index after 12, I don't need to look at because it's sorted, right? That's the assumption we're making. So we can just ignore that. So then what we're going to do is we're going to take a new subarray. We're going to say our area of search is now everything behind the value 12. This could be these 4 numbers. It could also be 1,000 numbers. Doesn't really matter, right? We're just saying, I don't need to look at everything else that's happening above that. So then we do the same exact process, but now we're just looking at these 4 numbers. So we're going to find that middle point. You look right here. Okay, there's not really a middle. So let's go ahead and maybe round down. We'll take a look at 6. Is 6 equal to 9? Nope, it's not. Right, 9 is actually greater than 6. So what that tells us is that the target value is somewhere up here. But we've already done a check and we know we can already discount all of these values, right? That was our first value. So the subarray we're looking at next is just these 2 values. We're going to do the process again. There's no middle, so we're going to round down, right? So then we take a look at 7. Excellent. 7 is not equal to 9. 9 is greater than that. So we follow the same process. We go, okay, well then it has to be above, right? We only have one item in that smallest size subarray, that small list, at which point we compare. 9 does equal 9. That is indeed true. So we just had to do a few different steps to get to our target value. Let me pause there. Any questions on this? When we start getting into real situations, it can get more confusing. But any questions on this? Yeah, correct, Omar. So the subarray doesn't include the middle number from the previous step because we already checked it, right? We already checked it and said, oh, that's not equal. That's not the value we're looking for at all. Each time we're getting a subarray, we're assuming that subarray has the capacity to have our target value. So it's more efficient for us to exclude that value. All right. So we just walked through this down here. You can read through this as well. But again, we're just sort of chunking. Yeah, we're taking little chunks of the array, cutting it down smaller and smaller until we find that number. Let's take a look at this next example. We're looking for the value 16. So with that in mind, I want to know again, what are the numbers we're going to look at to get to the value 16? We can see here 16 is indeed in the list, but as far as binary search is concerned, what numbers are we going to look at on our way to finding that value 16? All right, we got some suggestions coming in. right, cool. Yeah. So this time it's even a little bit shorter. So same sized array, right? So we're going to first find the middle point. Middle point is right here. We're going to go ahead and just round down, grab the value 12. Is 12 equal to 16? No, it is not. In that case, we will go ahead and compare, is 16 greater than or less than 12? 16 is greater than 12. So we know 16 would have to be somewhere in this array that's at the latter half of it, right? So this becomes our subarray. We're then going to check the middle point here. The middle point, we do actually have a middle point. It is this index, is this value. We checked does 16 equals 16? It does. Great, we're done. We found it. So very, very quick. One thing to note, if we take this and flip back to our first example here, we're searching for 9. Number of steps was actually very similar to linear search. So if we followed linear search, we would check 3, we would check 6, we would check 7, we would check 9, right? If we're doing binary search, we're checking 12, we're checking 6, we're checking 7, we're checking 9. They actually have the same level of efficiency, right? In the second example, this is much faster with binary search. So with binary search, we just did 2 checks, right? We checked 12 and we checked 16. With linear search, we'd have to check 3, 6, 7, 9, 12, 14, 15, 16. Finally there. So as we discussed, binary search is really best with larger and larger data sets because each time it makes one of those slices, it's really improving the number of steps we'll have to take to get there. So in a smaller subset, a smaller array, it may not really matter too much if you use linear search or binary search. All right. Feeling okay? A little mixed about it. All right. Hopefully process-wise, it's feeling pretty understandable. Now it's time for us to figure out how are we going to turn this into code. So we can think through this process, right? We could follow the steps. How do we want to start to turn this into code? So we're going to give you all a few minutes now. We're going to write some pseudocode for the binary search algorithm. Your pseudocode should describe the steps the algorithm takes to find a target value within a sorted array. Remember, pseudocode is a way to express an algorithm in a simplified manner using plain language and logical steps rather than specific programming syntax. So here's some of the guidelines here that walks you through what the process is for binary search, as well as a few things to keep in mind. So we're going to assume you have a sorted array of numbers and a target value that you want to find in that array. Your pseudocode should start by identifying the initial search boundaries. For example, think about the whole array to begin with, the boundary being the start of the array and the end of the array. You want to be able to describe how to find the midpoint and repeatedly have the search space. Include the decision-making process for determining whether the target is in the left half or the right half of the current search interval. You want to be able to specify what happens when the target value is found, as well as what to do if the search interval becomes empty. And of course, just a little bit here. Make sure your pseudocode is clear and easy to understand using step-by-step instructions. Just don't forget to do that easy part. So we want to write out some pseudocode for this binary search process. So remember, we talked about pseudocode in our last lesson. A couple of just suggestions, reminders here. You can use some of these keywords like set or init. There's no really right answer here. You can also just describe it a bit more, right? So you could say something like, assume our array is sorted. Assume our target value is set. What are you going to do from here? However you want to describe this is up to you. We want to get it close to a programming like language, but not just JavaScript, right? That's not actually what we're doing here. Okay, here's the thing we should do. Let me give you all a moment to get started on this. Just try and type out some ideas, start to brainstorm. Give you all like 3-4 minutes or so. Once we get to that point, I'll check in with you all and we can start to brainstorm a bit together on what this algorithm might look like and how you might type this out. All right, take the 3 to 4 minutes. I'll put a timer up here. All right, excellent. Welcome back, y'all. Let me share my screen. Okay. We're here, final challenge for binary search. Welcome back. I hope you had a nice little break. I got some nice ginger ale. My tummy's is still a little rumbly. It's tasting very good at the moment. Seeing some very uh noticeable gifts. Interesting, y'all. All right. So our lab for today is movie time search engines. This is very similar to what we just did, I promise, but we're going to use some more relevant data now. So the idea is that you're going to create a simple movie time search engine using JavaScript. It's going to allow us to search for movie times within a sorted list of show times for the day, and we're going to use the binary search algorithm. So the data set that you should be able to use is down here. The target show time we're looking for is this one right here. You'll notice these are in military time or that they are sorted in this list. So what we want to do is finish out this function. You'll probably notice taking a look at this looks pretty familiar. It's pretty familiar to the binary search algorithm we just put together. We have a start, we have an end, there's a middle getting calculated here. You have 3 to-dos. You're going to check if the middle position holds the target show time. If yes, go ahead and return some kind of success message with the show time. Then you're going to, if that's not true, we're going to check if the show time is earlier than the middle show time and adjust the end position. Or the target show time is later than the middle show time and adjust the start position. That is the plan. Any questions on your tasks? So we're pretty much just going to be translating the binary search algorithm we just put together. And we're going to be implementing it within this new function, which is using movie showtimes. Okay, it looks like no questions. One thing I'll note before I pass it over to you all for a few minutes to finish this out, you may be wondering, oh, how do I compare these different movie times? These are not integers, right? They're actually strings. Well, thankfully, JavaScript has you covered, and the military time certainly helps as well. They say, is 1830 greater than 1130? That returns true. Meanwhile, if it's is it greater than 2000, that is false. So you shouldn't have to change too much in the algorithm we just put together as a team. All right, I'm going to pause there. I'll pass over to you all. I'll put up, I'll say 4 minutes or so, 4 or 5 minutes on a timer. And once we come back, we can walk through the solution here. If you have questions and you're feeling stuck, you can always go back to one of these previous pages where it's walking through the pseudocode, where it's walking through different parts of the steps to better understand how we want to write this code. All right, good luck. Excellent. All right, so how did it go? Just it looks like it got it working for you. Nice. How are other folks feeling on implementing this? Feeling good? Feeling stressful? Feeling nothing? Just the cold nothingness of space and stressful but done. That's how I usually feel. I sympathize more. All right, any other thoughts? All right, well, let's talk through how to accomplish this. So again, we're already set up in a pretty good space compared to an empty function, right? So we have a lot of the components of our binary search already set up. We have our start and end indexes. already established. We have our while loop already established. We have our middle value already established. And so what we need to do is just set up the conditional statement that will either return the target value or adjust our start and end indexes. Let's go ahead and do that. So we're going to check to see if the middle position holds the target show time. So to do that, we would do something like checking if show time's at the middle index, if that's equal to the target show time. So that's step one. I guess actually I can leave that there. If that's true, if those do match, then I think it says here to share a message, right? Da, 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 da. It doesn't say anything. Over here, just return a success message. All right. Maybe we could do something like this, where we say, yes, there's a show at your target time. Let's go ahead and it's actually, let's just work right off the bat. 0, 1, 2, 3, 4, 6. No, it won't. Okay. We'll finish out the algorithm and we'll test it out. All right, so that's our first case is if the time does match, then fantastic. We can go ahead and return that. Otherwise, I'm going to do some other stuff here. I'm just going to get this frame together. Okay. Otherwise, if the target show time is earlier than the middle show time, so let's do this exactly as it's asking. So it's saying here target show time is earlier, so less than show times at middle. And then we're going to adjust something. So the target show time is earlier than the show times at middle, right? In that middle point. That means we want to take all the earlier times, right? We want to take all the earlier times. So to do that, we're going to adjust the end position. And so for this, we would say end equals middle minus 1. The other scenario is that the target show time is after the middlest show time, in which case we want to take that after part, that later section. So we would bump up the start index and set that equal to middle plus 1. Notice depending on what you choose here in terms of greater than, less than, the order of these, which one of the conditionals contains where you're going to adjust the end versus which one you're going to adjust the start, that may change. The concept is still the same, but the actual code might look slightly different. Either way, it works. Let's go ahead and run this now. Oh, I did something wrong. Hold on, let's run that. Oh, because I'm in Node. Hello. Okay, there we go. All right, so our search here, searching for 1545, that does indeed find the time here. Let's try some other times. So we do 2215, that's at the very end of this array. We see, yes, there is a show at that time. If we set a time like, hey, who wants to go at 8 in the morning? We're going to receive showtime not available. Any questions on this code? All right. So I guess just a couple things I want to note here as we're getting to the end of this lesson. So this is the algorithm that we've set up. As sort of pointed out, and I feel like it's just important to say, the guiding principle of this algorithm is that we are dividing the sorted array in half and searching that subarray where it makes sense. The details of it can shift. What I mean by that is, again, if you want to check less than, greater than, that's not an essential part of the algorithm, doing one of those first, right? In this case, it doesn't necessarily matter. Whether you round up or down, that doesn't actually really matter. What matters is that as you are looping through this, as you're checking the values, you're cutting the array in half and adjusting the indexes so that you're always searching a subarray. That's the most important point. The reason, again, we are learning binary search, as a reminder, is that it can be, particularly with larger data sets, much more efficient than linear search. Linear search is going to start from the very beginning to the very end, whereas binary search will continue to cut in half. I believe it's our next lesson. We'll talk more about how we can measure that more concretely. But in this case, just the thing to remember is that, if you only have 3 items, it may not really matter which one you use. But if you have 3 million items, it's going to be much, much faster to search binary search. And maybe that sounds hyperbolic, but, think of, I don't know, any popular social media app, any search engine, right? There's millions, millions, millions of different items they may need to be searching through to find the thing you're looking for, find the profile you're looking for. So this kind of process is actually really common in software development. Another important point here is that for binary search to work, the one constraint we have is that we must sort the list as well. So the list must be sorted in addition to it. All right, I don't even think there's a conclusion slide here. That's it. That is the end of it. So we've walked through binary search. That is our algorithm for today. I believe not tomorrow, but Thursday, we'll be going through algorithm complexity, and there we'll learn more about how to talk about different efficiency levels for different algorithms. So that's the plan for this. Is there any other questions on this or why we're using this? Let me know. I do kind of want to gear shift here. We still have some time left in our class. There's no more content on this for today, but I saw that someone, Juan, put in a poll into the extra help channel. It seems like everyone wants to talk about project 9. So I can pull that up. We can spend a little bit of time going over that. But let me ask you all, what about project 9 was feeling difficult, stressful, not sure how to figure this out, just have questions about it? What are some of the things that you all want to discuss with project 9? Maybe it's just that you love React so much. You're like, I want to see it done again. It was just so cool the first time. Just React, doing API calls. All right, pulled up project 9. It's a data gallery app. What questions do you all have on this? Yeah, thanks for clarifying, Veronica. Like Veronica probably has some good insight into some of the issues you all are having. If she's saying this, makes me trust it. All right, so yeah, we can talk about file creation and organization as well as how APIs work for sure. Yeah, that sounds good to me. Any other issues that you all would like to discuss? Right. Well, we can start there and see where we get. So just open up this project. I'm gonna go ahead and I'll just talk through some of the files over here first, just to discuss. Then we can bounce over to APIs and we can talk about new files as well. So this is the project that you all had started with. So you'll notice a number of different files and folders within this. Something that be important to say, and maybe David was able to talk about this, is that there are a lot of conventions, particularly once you get to larger projects, that we follow some of it is just convention, right? You can name things, just like with the variable names, you can name stuff whatever you want. You have lots of flexibility to sort of make things look the way you want them to, but we might follow certain conventions just to have it make sense and make it easier for other folks to be able to find the code you're working on and how everything's structured. All right, so what we're looking at here is our typical React project. Looks like set up with Vite. We have some files here that we don't really need to mess with. I think you all probably had done a tiny bit of work on the package.json, particularly when installing things or maybe setting up some of the build stuff with Vite or like the dev script. So this, is important, but typically when we're trying to solve our challenges, like actually add new features, we may not really be messing with this. There's a number of other sort of configuration files here that we may not really be touching too much, right? So we have our vconfig file, probably don't need to mess with that too much. Our gitignore, our eslint, these are all things that are kind of part of the package. The entry point for our application is our index.html file. That's the thing that has our div ID of root. And that's going to attach, or what's going to get attached to that is our React application. And all of our React specific code is really inside of the source folder, right? So we have our app.jsx. That's our main entry point file. We also have actually I should say our app is our first like component. That's maybe a better way to put that. And then our main .jsx file, that is where we're attaching our React application to the element with an ID of root, which as a reminder is this thing right here. So generally, when you're working on, once you have this sort of set up, generally when you're just working on adding new features, you're mostly just going to be working in source and working with these kind of JSX files one after another, right? That's the main process they're going to be following. So when we look at our instructions for this project, our instructions here are to create a React application that displays a gallery of different data points fetched from an API. The application should include a main page with a gallery view and a detailed view for individual data points. And we got features gallery component, create a gallery component that displays a grid or list of data points fetched from the chosen API. Each data point should be represented as a card or an item in the gallery. We have a detail component. So that's when we click on one of our components, we're going to get more details about that specific resource. And then we're integrating some kind of API in here and some navigation from React Router. Love this too. Add a search, pagination. There's all kinds of cool stuff we could be doing, right? So I think if I were to start this project, I'd be sort of looking at this and saying, okay, so I really have, seems like just two different views here, right? We have our gallery view and then we have our individual view. That's not necessarily resonating. It's a website that would have this. I'm trying to remember what I showed before Drivel, I think. Let's pull this up. Drivel is a cool website for designers. So just to give us an example of somewhere maybe to start from, whatever we put together may not look as nice as this, but hey, it's a good starting point. So this might be our gallery view, right? We have a bunch of different cards that have some cool styles in them, cool images. And then when we click in on one of these, we get some individual view here, right? That has some other stuff on it. Cool. So that's what we're trying to create. So there's lots of ways to start a project like this. What I would say is there's two main challenges here. Maybe there's three main challenges, but I'll say one main challenge is just getting things to show up on the page, right? So we need to have these two different views. One is the gallery view and one is the individual view. I think that's kind of tied to this navigation bit about React Router. We want to be able to switch between the gallery view and the individual view. And the additional thing is the API, right? Ultimately, the data we want to receive is from the API, and that's going to get integrated into our different views. So it can maybe feel tempting to do kind of everything at once, all at the same time. But I think that is a good way to find ourselves confused if this is content that doesn't feel like 100% like you're 100% on it. So what I might do is just sort of figure out, okay, let me try and just put together a gallery view here of something, even if it's just like a bunch of list items to kind of set up my structure. And then I can work backwards to replacing that data with an API. So I think that's where I'll suggest we start. So because it's pretty loose in terms of what kind of topic this can be, what kind of API this can be, I'm gonna use really generic terms here, and then we can make them more specific as we choose a specific API. So if I want to show a list of items in React, I'll first need some kind of list. So in this case, an array could be really great. I'm just going to say resources here, just so that we can have a generic term. And again, we'll swap that out with something. I'm going to say I'll pick like let's say students, just so I can pull some names here. I'm going to set this as an array of objects. We'll add Omar here. I'm just looking by who I can see in here. And all right, that's who's chatting in lately. All right, so we have our array of objects. So the first thing we're going to try and do is just to get multiple items to show up on the page. All right, so I just want these names to show up on the page. Right now, if we take a look at our page over here, it just says hello world. That's coming from this return statement, and it has an H1 where it says hello world. Excellent. What can I do? Getting back into React land, moving away from binary search, right? What can I do to have all of these names show up? What kind of tools might I need to use? What kind of syntax might I use to get all of these names to show up? What do you all think? Hmm. What do you think? What are some of the tools we could use? Some of the syntax we might use to get all of these names to show up. This right now is our gallery, right, of individual items. We're going to worry about the API stuff in just a bit. Right now, we're just going to focus on trying to get this information to repeat and display on our page. All right, I got one person typing in, but the rest of y'all. Sorry, so since it's a function, we can just call the function. Sorry, can you say a little bit more? So the function here is app, right? But app is our component. We can't necessarily just call the component within the component itself. All right, sounds like folks are not too sure. So if we have our array up here of items, we have a return statement. This is what's going to return and display on the page. So I guess just as a reminder, if we edit our JSX within our return statement here, it's going to show up on the page. I mean, function components using the index. Components. So in terms of function, the only function here right now is app. Can loop over these, and we can use the index within this array to have different elements show up. Maybe that's kind of what you're trying to get at. So if I just want a name to show up here, let's say it's just the first name. do something like resources at 0 dot name, right? That's going to grab this array, the first element in that array, and just the name. So we can see a name shows up here. Excellent. But we need to loop over all of these names and somehow get all of them to show up on the page. So there's a couple different ways we can do that. So remember our curly braces within JSX, that's allowing us to write JavaScript code within the JSX. So one common way to do this is to write some kind of loop statement inside of here. In this case, because we want to return a value, we might do something like .map. So remember, .map is a native array method. It allows us to loop over an array and return a value. That returned value will be at each spot in the array. So if I say resources.map, this is a higher order function. So I'm passing a function into it. This is going to be our student. Within here, I could then do something like return. Right now, I'll just do a paragraph. Student.name. Let's see what happens. No, what did I do? Closing tag. Oh yeah, hello. I did not include a backslash there. Let's go ahead and fix that. And we switch to something else. What am I forgetting in here, y'all? Resources.map. Oh, maybe I just don't need this. Oh, very particular. That's all right. That's why we love React. All right, so just had to fix some of my syntax issues, but once we did, we got our resources.map. This is returning an array where each element in the array is a JSX paragraph. Because of how React works, we can then pass that in, and we end up with 3 distinct paragraphs with everyone's name in it. Cool. This is basically our gallery, right? Whatever data we get, as long as it's an array, we can just swap out the array, this array, swap out some of the values here, and we'll get a gallery to show up, right? Now, something I forgot to do here with repeating values. There's repeating values in this code right now. What else do I need to do here? There's something I've forgotten to do, an attribute I've forgotten to add. Do I remember this part? What do we need to add whenever we have repeating elements in our React applications? No. Is it all gone? Is all the React content gone? It's washed through. All right, let's see if we can take a look at our console here and see if anything shows up. It may not, because I think it's within this. Yeah, this actually looks kind of okay. All right, do you remember seeing this? Does this feel familiar? Each child in the list should have a unique key prop. I don't entirely remember. I taught the React stuff in the last class, but I feel like this was covered like 3 or 4 times in a way that I vaguely remember being like, I think we talked about this. All right, so in this case, whenever we're looping over, elements, we'll need to add some kind of key prop. This is how React can tell there's a difference between all these different items. So there's a couple different ways we could do that. You could add the index here. I add an ID, a unique ID to all of these. We actually just say student.id, and that should fix the repeating element issue. Okay. Now, ideally, if we're really doing like a student app, hopefully our gallery would look more interesting than this. But to be clear, this is the concept, right? We have an array of content. We're going to loop over that content and display each one of those items on the page. We could do something much more interesting looking, like what we saw with Dribble, where we have maybe like a flexbox scenario or a grid scenario, images, little hover options, right? But in terms of the basic structure, this is actually kind of what we're trying to get at. Okay. What Veronica suggested we talk about was file creation organization. So with this works, right? This is okay. This is fine. We could just keep adding to our app component. But we're probably going to assume that, hey, like this isn't going to be a paragraph the entire time, right? Maybe we'd have a picture of our students. We'd have some information about how they're doing in the class, right? We might have a bunch of different details, even in our gallery view, right? So what I might want to do is create a new component for each student. So let's go ahead and do that. The first thing we could do, because it's JavaScript, we can do whatever we want. We're just shooting from the hip here with JavaScript. So we actually create our component within the same file, just so we can kind of see everything together. So I'm going to create a new student component. It does indeed just look like a function. In this case, what I'll do is I'll return. I'm going to return a paragraph. And we're going to end up swapping out this code with this. So what we'll assume with our component is that we're going to get access to that student object. All right. Do you guys remember the name of this? What do we call this in React? All right, we're accessing the what of our React component. What's the name for this thing? Yeah, that's all right. Perfect. Yeah, so this is our prop, right? We're expecting a student prop, and then we can use that within our component. So to use that, I might do something like student.name. Great. Now we have our very simple, but it's a separate student component. Now let's figure out how to use that down here. So instead of this paragraph, we can put student. And instead of doing all of this, we can just pass in something like that. We'll still have the key here. Then we also want to pass through the prop. Passing through our prop of student. And then we're setting it equal to, we're passing in the value here. And my apologies, I forgot this earlier. The props come through as an object where the key is each prop and the value is whatever's been passed in there. Let's see if this works. What we should expect is the same thing. There should be no changes. All right, excellent. Here, just to let you all know, I'm not just goofing around with you. I'll make a couple of changes here. Perfect. All right, so we've now replaced our paragraph tag with a component. Now, again, I know this is really simple. At this level, literally all we were doing is just adding paragraphs. Probably wouldn't do this, but we're assuming, right, our student individual item or individual card is going to have a lot of styling. It's going to have, different components to it, a name, a picture, all kinds of different stuff. At this point, we've extracted it out. We've abstracted the concept of student and we've put it into its own little space. So the next thing we could do is put this in its own file. Well, we could have all of our components within the same file. That will, I promise you, make you go insane after you start to write more than a few weeks worth of code. In a React application, in like a production environment, you're going to have probably thousands of components. Lots and lots and lots. So just putting everything into the app.jsx, it's not going to make any sense at a certain point. It's going to get really confusing. So instead, we create maybe a new file and include this student component within it. Over here, how we do that is we go over to our source. We create a new file here. In this case, it's a typical convention to capitalize your component names. We can have our student.jsx. And then to get this to work, it's actually pretty straightforward. We need to have our actual component within there. And then we'll also need a line like this as well. We need a line like this. Except instead of app, we're going to have student. Someone remind me, what is this about? What's this export default about? What does this give us access to? All right, I see some folks typing. What does this export default student give us access to? What's it doing for us? Why do we need it? All right, well, as a hint here, you may have noticed that this page over here has gone empty. And so at some point refreshed and tried to reload from our app.jsx. So the problem is that we don't actually have student, the component, defined. All right, we've moved some code around, we don't actually have it defined. This means we'll need to import our component, right? We'll need to import our component up here. We could do something like import student from, and then we give it a path to the file where we can access that. That should give us access to the student component from the student.jsx file. The way that those files get connected is via this import statement, I should say, and via this export statement. So we're saying by default, export this student component. And so when we import it, we should hopefully then get access to it. And we now have our student component getting used in our app.jsx, but that student component lives in an entirely different file. It lives elsewhere. All right, now again, why might we do this? Well, I'll tell you, this is better. That's reason one, trust me on this, this is better. Why so? Because as we continue to update our student component, we're going to add, divs, additional JSX elements, styles, all of that. This page will get more complicated, but our app can still function the same. It can still function the same. We don't have to make changes all over the place or grow our one file into some huge, large file. It also makes it easier for us to segment and pull apart our application to make it a little bit easier to locate any issues in the future or to add new features. So for example, we got a feature request like, hey, for each student on the gallery page, go ahead and add this color, change this part of the text, go ahead and underline this kind of thing. Makes it easier to be able to just define a specific component and just have to work with that code, as opposed to having to read through one big file to understand exactly what's going on. So there's definitely a few benefits we can get from starting to break out our components. Okay, we've done a tiny bit here. Veronica, does that kind of address some of the, file stuff? Cool. I'll say there's no right answer to this process. Like you can continue to extract stuff at any level. So for example, we might say, okay, well, that's our student, but what about this? Should we extract our list of students? And maybe you want to do that, right? So one thing I could do is I could say, okay, well, I'm gonna make a new file called student list.jsx. Let's say student list. We'll pass in students as a prop. And then we're going to export it. And then here, I want to do something like, I just want to say, oops, I'm return here. List of all students. And then I want that full list. So I might, oops, sorry about that. Might do something like, I'm going to cut this out. And I'll just put this right in here. There we go. Gorgeous. So I'm putting together a student list. That student list is going to pull at our student component. That's going to actually display it, so on and so forth. This should work as well. There's a couple adjustments we'll need to make here. I'll need to import the student component into the student list because that's where it's getting used, right? This all seems good. Over in app.jsx, we'll import our student list. And then we can call that student list. What did I call it? Students, probably. Let's see. Let's see what that does. Blew something up. Let's take a look. Da, 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 da. Got something in here. Got a curly brace. Oh, because there's not two elements. Oh. Let's see if that fixes it. All right, we're slowly getting back to where we need to go. All right, so we have our app. Should have hello world here. Great, we import student list from studentlist.jsx. This word is starting to look like nothing to me now. It's all starting to look the same somehow. We're now pulling in student list. I'm still getting an error, it looks like. Students.map is not a function. Oh. Y'all just let me sync over here. Looking at these missing curly braces, and we're like, well, I'll probably figure it out at some point. All right, what do we do? What do we do? Okay, that should be it. All right, fantastic. All right, let's talk through what we did with these new files. We have our app.js. That's the entry point to our application. What we decided to do is, okay, if we have a gallery view, excellent. Let's go ahead and put together our gallery view. We're going to create a new component called student list that passes in all of our students. Great. Over in student list, we have this heading right here. That's going to give us some textual context of what's going on. You can imagine here we have lots of styles to make this look really cool. Maybe this is where we have our search functionality, right? This could hold a number of different things. Then we're using our student component. Our student component lives right here, and right now it's just a simple paragraph, but you can imagine again, this would have more text, more styles, all kinds of stuff. Let me pause here. Any questions about creating these new files for different components? Any questions here? All right, Umar says, this part's clear. Cool. All right, well, so then let's talk about the API aspects. We have this structure set up, and now we need to access the API. What are some of the APIs you all sought out? What APIs were you trying to use for this project? Or what were some of the APIs you all worked with as part of the classes that you all were doing together? What were some of the APIs you remember from probably now a month or two ago? Anything coming to mind? All right, well, there are lots of options. Oh, I see some folks typing. Oh, anime list API. All right. Cool, cool. People like anime. Love that. Thank you, thank you. Yeah, we have the Star Wars API. I think that's part of lesson. Thanks, Omar. I love it. Cool. All kinds of stuff, right? All kinds of APIs that allow us to return data and work with that data to build our own applications. Pretty helpful. So in terms of what an API is and why and how we're going to use it. So to step back a little bit, so an API is a program running on someone's computer, and our requests are just us going and saying, hey, can we have that data too? Do you mind if I borrow that for a moment? So the Star Wars API, it's just a program and it's designed to receive requests. Those are going to be our HTTP requests. And based on the information we provide, such as, hey, is it a GET request? Is it to this particular endpoint? This program is going to decide, okay, here's the information you requested. API stands for Application Programming Interface. That interface part, that's pretty important. That's the thing I would try and remember, because all it's about is just building an interface between the consumer and the client. In this case, Star Wars API has all the information we want, and we just need to figure out how to request that information. Right? That's its main goal. So building a server and API can be complex. It can be simple. That's not something I think we've covered in this course as of yet, but you all are have a lot of the skills you would need to build one. So it's not really that far off. The way we figure out how to talk to an API is usually through its documentation, right? So ideally, a good API has good documentation that allows us to see how we can request different types of information. And you can see here, there's lots of details about how we can request information about certain people, about different films in Star Wars, the universe, all kinds of different stuff. Okay, so that's an API. In JavaScript, to access an API, we need to use the fetch keyword, right? That's the word we've learned. That's the function we've learned in this class, is to use the fetch keyword. fetch is an asynchronous function. And I'm sure you all had tons of fun learning about promises and asynchronous actions. It can be pretty tricky for sure. It's an asynchronous action, which means when we make that request, it may take a moment to get back to us the information. So that's why when we're having to add a bunch of like kind of special rules to work with APIs, it can feel a bit annoying. That's because our programs want to run, and even while we're waiting for the information to come back, we want to provide some feedback to the user. That's why we might have to add some extra syntax, jump through some hoops to get that API data. Okay, we're at about 10 minutes left. Let's see if we can just pump out one of these requests and see if we can start to get something together here. Hopefully this will just help jumpstart some of y'all in terms of getting this completed. So I'm going to add use effect here. Hey, does anyone remember what this little empty array is at the end of use effect? Does that feel familiar? Something about use effect in here. What was that about? What was that end array about? Anything? No, all right. So use effect, right, is a method we can use within our applications. This allows us to sort of like capture some asynchronous content. This array down here is our dependencies. So depending on what is within this array, that's when this use effect function, that's this function, will run. When we add an empty array, that means we're just going to run it once when the component loads. That's it. That's its job. What I'm setting up here is a function within here. I'm setting to be an async function. That's going to give us some special syntax to make our fetch request. And then I'm calling that function. I'm just going to go ahead and console log out here. Just something so we can try and see if it works at all. Looks like something's mad at us. Use effect is not defined. Yeah, okay, cool. That is my bad. So use effect is not defined. That's the error that I'm looking at. Up here, that makes sense. I have not defined use effect. Let's go ahead and import that from React. Now we're cooking. Now we're cooking with gas. Now we have our question marks showing up here, right? Okay, excellent. Within this function, I guess let me step back and say, this is some of the setup we need to do to make our API call. This is just part of what we need to do in React to make this work. For more information, I would definitely suggest you all head back to those previous lessons and it'll talk more about this. Inside of here, we need to make that fetch request. So we can take a look at the documentation. I was suggesting grabbing planets. Let's see if we can just grab all the planets. So we're going to make an HTTP request to swappy.dev/API/planets. Should be able to use the fetch keyword here. So I'm going to say response equals await fetch. There we go. So await, right, is a keyword we can use when we have an async function. Async and await go together. Await is used on a promise, something that delays, it waits until it's finished before returning a response. This is essentially saying once this fetch request finishes, the end result of that, go ahead and assign that to the content to the left. Let's see if we can log this out. There's additional steps we need to follow here to get this to work. Let's see if anything happens here. I'll open up our console. Cool. What is this? What is this? What is this? So it looks like we got something. We're seeing some good signs in here, right? We see status 200. You might have seen that a few different times when you're playing around with different API requests. That seems like okay. things are going good. We have this okay keyword that is true. That means things are going pretty great. There's something we need to call here. Something we need to call here to get this data back, though, in a format that we can actually use. Right now, this is kind of like a strange little object. It doesn't really have the information we want. Does anyone remember how we can access the data within here? Yeah, I haven't done this in a while, but I think it's something like this. Let's give it a shot. All right. So how fetch works, right, is we're going to get back the initial response. We want our response in JSON, JavaScript object notation, so that we can actually work with it within our component, right? To do that, we're going to call response.json. That's a method. This method returns a promise, so we can use the await keyword again. Once that method is done with its work, it'll assign all that value to JSON. And then right here, we're just logging it out. Okay, well, what I see here is we did receive a response. We got a positive response, and within this response, there's some details here, and we have results of, I believe these are the first 10 planets. And we can see here this next keyword is giving us what the next request would be to get the next 10. So what that means is json.results. That'll give us access to these 10 different values right here. Okay. So what can we do with this information? Well, you'll notice this array. Oh, this is an array. Oh, this is also an array. It's gonna go together maybe. So how do we do that? Well, we could do something like setting our state. So we might do something like planets, set planets, set state, yeah. Let's cut out these guys. Say set planets, json.results. And what I'm going to do down here is instead of resources, I'm going to pass through planets. I know we've kind of messed up some of the naming. We have students here for our earlier example, but now we have planets. Let's just see what happens. All right, probably got some kind of error. Set state is not defined. Use state. Hello. Hello. Oh, yeah. Yeah. This is pretty good, right? This is kind of where we're trying to head. Just to recap those last few steps here. So I know I was doing that probably a little quick, but it's all stuff you hopefully have seen before. So we set up our use effect. That's allowing us to make our API request. Our API is just going to give us back data. This whole format, I know it seems like a lot, but this is just a way for us to get access to the data within that API. Once we have that data, we're able to then tap into different React tools that we have, in this case with set planets or with use state. That's giving us access to update state. And once that state is updated, we can then pass those values down as props. Because the data within here also has a name keyword, we actually didn't really have to change any of the rest of our code because we were using name there as well. So with this, we have our gallery page, right? This is giving us a gallery page. There's more style that needs to happen for sure, but this is our gallery page and it's displaying all the different planets from our first page. So the next things we need to do for this project are a couple things. One, we need to make this look nice. But two, we would want to, when we click on one of these, it then brings us to a new page. And that has to do with the React router and navigation content that you all worked on as a group. right? So that's kind of the last step here. But hopefully you saw in terms of how we put this together, like as opposed to starting from the API and trying to design everything out, I just tried to start from a place of, okay, well, how do I get the structure up and running? Because now if we want to, let's say we wanted to swap from students to planets, we could rename some stuff. But now we just need to go into our student, perhaps we'd rename this as planet and start to add more styling, make it look really neat, et cetera, based on the data we have from our API. All right. I've been talking for a while. Is this helpful at all? Just get like an emoji reaction of how you're feeling at this moment, and then we'll close out for today. Any thoughts or feelings? Glad to hear it, Tatiana. Oh my gosh, I'm not sure what those eyes tell us, but I hope it's generally positive. Like those little sideways eyes are kind of like a ooh, ooh, ooh. All right, well, I hope this was useful. We may have some time next time. I see joggers. We may have some time next time to continue on this. Um, if there's more questions, please just let me know. You can put it in live chat and I'll scan through it for our next lesson. With that, though, we can close out today. Thanks for your attention today. I know we covered a lot of stuff. We covered binary search, and we dove back into Project 9. Hopefully, this was a helpful exercise, and hopefully, you all feel good about binary search. It's a pretty neat algorithm. All right, I'm going to stop there. Veronica, anything to close out?